Once a simulation study has finished running, the next step is to analyze the results. The result plots that are shown automatically are a product of what we have set up in our simulation options menu, but there are plenty of ways that a user can add, change, and manipulate the appearance of these result plots after they've been created. Let's look at how a user can change a plot's appearance from something like this to this very quickly and easily in this 2-minute tech tip. Here I have an example of a stress plot from a linear static analysis, and now I'd like to make some changes to help me analyze the results. I'd like to change things like the stress type, the legend size and notation, and even the colors used to give me more of a distinction between my stress values. When a user wants to change a chart's definition, options, or settings, the most common way to access those menus is to right-click on a result plot and select them from the pop-up menu. But what's not as commonly known is that those same options and more can be accessed by right-clicking the legend. You have the ability to change the stress component that's being shown, the fringe options, and you can even show and hide the mesh. You can also change the minimum and maximum values on the scale to whatever you'd like by simply clicking on them and inputting your desired value. Here I'll change the maximum value to the yield strength so that I can easily see any areas over the yield strength. If you want to return to the plot maximum, you can just click on the value again and select Reset Maximum to Automatic. Some other nice display options live in the Chart Options Property Manager, which you can also access by right-clicking on the legend. Underneath the Positions Format section, you can change the size of the legend to be thinner or thicker, and change the number format and precision to something that might be a little easier to read. Under the Color Options section, you have the option to change the scale used from the default colors to scales like rainbow, grayscale, and user-defined, where you can create your own or optimize for color blindness, which gives a really nice distinction between different stress values. You can also check specified color for values above yield, even more clearly identifying failing regions. Finally, if you want to know where the minimum or maximum stress points are, you can check those options to turn on flags in the graphics area. To learn more about finite element analysis, study types, strategies for validation, and more, be sure to check out our Introduction to FEA course, where you'll find dozens of lessons and 2 unique case studies covering all the fundamentals and best practices to successfully simulate your designs. Thanks for watching.